Good day, guys. This is your data engineer. Today we'll be doing functions, particularly looking at the hyperbola function in detail for grade 12. So let's get on with it. The question says, consider the two graphs of g of x and h of x. The first question goes as, write down the domain of g. So here's the graph of g. When it comes to the domain, these are the values of x for which the graph of g is applicable. So the answer here would be x is the element of real numbers. But now you have to be careful when it comes to the hyperbola. The hyperbolas are generally discontinued at the asymptotes. So in this case, you've got the x asymptote of x is equal to minus 3. That is going to be the flip sign of the positive 3. So since the graph g will be discontinued there, so you'll say x is the element of real numbers, where x is not minus 3. So that's how you're going to represent the domain. And then when it comes to the second question, write down the range of h. Likewise, the range are the values of y for graph h, where it is applicable. So here you write y, so that's not going to be x, I'm sorry about that. So that's going to be y is the element of real numbers, where y is not. So what is the asymptote of the graph of h? That's going to be 2. So y is not 2. So that's it for the asymptote, for the domain of the graph of h. Now let's continue for the next question. If the graph of g is shifted so that it coincides with the graph of h, the first question is, how many units must the graph be shifted horizontally? So this speaks to the horizontal shift for the graph of g so that it perfectly coincides, meaning for the graph of g to have the same values as the graph of h in all respect. So for the basically, maybe in layman's term, how can you change this x plus 3 so that it looks exactly like x minus 3? What changes would have taken place so that it looks like that? So the change would be, I think you would agree with me, to shift it horizontally. That would be g of x is equal to, for it to look exactly like h, you have to add a minus 6 or subtract a minus 6 next to plus 3. So this would be g of x shifted by how many units? That would be shifted by 6 units. The question is it to the left or to the right? So basically, if you're subtracting a minus 6, you're shifting the graph to the right. Right? So it's shifting to the right since you're subtracting. But if you are adding a 6, it will have shifted to the left. But in this case, it's to the right. So this would be the complete shift graph, the complete graph that has been shifted to the right by 6 units. Now let's go to the second part of the question. 4.3.2, how many units must the graph be shifted vertically? So in order to look exactly like, remember, the graph h of x. So basically, what is it that you can add or subtract to minus 3 over 2 so that it looks exactly like it's 2 over here? So minus 1 over 3 is basically minus 1,5. So if you add to the graph of g of x 3,5, then you'd get a 2, right? So for instance, this is the g of x. If you add next to it 3,5, you'd get the graph of h of x, basically exactly h of x, because you have 6 divided by x minus 3. plus 2. So since we are adding 3,5, that means you are shifting the graph 3,5 units up, right? If you're adding, you're shifting up, and then if you're subtracting on the y values, then you're shifting down. I hope that's clear. Now let's move to question 4.4. Write down the equations for the asymptotes of G. Alright, so remember the graph of G. Let's just go up a bit. Here's the graph of G there. The x asymptote would be the flip sign of the 3. So you'll have x is equal to minus 3 as the x asymptote, and then the y is not going to change the sign, so you'll have y is equal to minus 3 over 2. That's the y asymptote. And then we'll move on to 4.5. Calculate the x-intercept for G. So for x-intercept, you know that is when y is equal to 0. So when it comes to working out the x-intercept where y is equal to 0, let's just go up a bit. Let's go up a bit for this particular question. So you've got g of x, let me write here. G of x is equal to 6 divided by x plus 3 minus 3 over 2. So this is all equal to y. You can just replace g of x by y. So if you set y is equal to 0, you'll have 0 on the left hand side, then on the right hand side 6 over x plus 3 minus 3 over 2, and then you'll take 3 over 2 over to this side, then you'll remain with x, 6 divided by x plus 3, then from here on you can just cross multiply. X plus 3 will come this side, and then 6 and 2 will come over this side. And then these you can divide by 3 again on both sides, so that you have x plus 3 is equal to, that will be 4, right? And then taking 3 to the right hand side, we'll have x is equal to 4 minus 3, which means x is 1. So the x-intercept would be 1 and 0. I hope that is clear. Now we'll move to the next question. It's quite a long list of questions, but we're almost done. Just bear with me. 4.6 says sketch the graph of G in your answer book, showing clearly all your asymptotes and intercept. We've already worked out the asymptote, right? These are the asymptotes. And then when it comes to the x-intercept, in the previous question we worked out the x-intercept of 1 and 0. The only part of the intercepts that you don't have is the y-intercept. So the y-intercept shouldn't be too difficult, because when it comes to the y-intercept, you just set x is equal to 0, then you calculate the y-intercept. So that means y is going to be 6 divided by yx is 0 plus 3 minus 3 over 2. Then this will be, it's basically 6 divided by 3, or if you want to do it the long way, that's actually 6 divided by 3 like that, and then minus 3 over 2. 6 divided by 3 is 2, then you have 3 over 2, right? So basically it's 2 minus 1,5, which is 1 over 2. That's your y-intercept. That would be 0. And 1 over 2 for your y-intercept. So now let's just move up where there is a bit of space to draw a graph. So you're just going to plot the y-axis, the x-axis, like that. And then remember, the asymptotes, you said it's minus 3. So somewhere here you have the x asymptote of minus 3. and then the y asymptote is minus 3 over 2. If you have minus 1, minus 2, minus 3 over 2 will be somewhere in the middle, isn't it? Yes, it will be somewhere in the middle, so just draw a dotted line across minus 3 like that. And then when it comes to the x-intercept, remember we calculated x-intercept of 1. Let's make a point there. That's where the graph will cross. And then the y-intercept, we said it's 1 over 2. So if you have 1 there, 1 over 2 will be here. Now we are ready to draw the graph. Let's change colors for this graph to make it look a little bit pretty. So just gonna draw. Maybe it's not the very best line in the world, but just make sure that you go through the y and the x-intercept and you do not touch the asymptotes, right? So the graph is not going to touch the asymptote until infinity. Also the y asymptote is not going to touch, so it's going to go like that. So this is supposed to be a curve, right? A very nice curve. Let's just go up a bit. If you'd want to continue this graph, it will go up something like that, never touching the asymptotes. And then the other half of the graph is going to be reflected here. So this is the graph of G. That will be it for this particular question. I think we are remaining with 2 more questions until we finish. 4.7 says determine the value of k for which h of x is equal to minus x plus k is an axis of symmetry for G. So we need to just work out the value of k. So what does the axis of symmetry for G mean? You'll realize that the gradient for this line graph, because this is the linear function, we have minus 1. So if the gradient is minus, that means it's going to be looking like that, right? So I'm deliberately crossing it at the point of intersection of the asymptotes of minus 3 and minus 3 over 2, because that's where the center between these 2 halves of the graph is. This line is the mirror image of the graph of G. That's what the axis of symmetry mean. So this is the graph. H of x is minus x plus k. So let's work out the value of k. You realize that this graph is passing through minus 3 and minus 3 over 2. So we'll use that point to work out the value of k. So y is minus 3 over 2 according to that point, and then x is minus 3. So let's just replace x by minus 3, then you have plus k. So this would be minus 3 over 2. Take this to the left hand side, you'll have minus 3 is equal to k. That means k here, if you work this one out, you'd get k is equal to minus 9 over 2. Right? So that's all we needed to do to work out the value of k. So if you want to write the entire function, the entire function will look like minus x plus minus 9 over 2, which is minus x minus 9 over 2, just like that. And then we are done with this question. Let's do 4.8. For which values of x will this graph here, which looks like graph of G, remember this is the graph of G, where the graph of G is greater than the graph of H, basically where G of x is greater than H of x, for which values of x. In order to answer this question, you have to look at your graph one more time. So this is the orange dotted line is the graph of H, and then the graph of G is this part here and that part. You'll realize that after x is minus 3, the graph of G is on top of the graph of H. So for this particular question, we'll say that would be x when x is greater than minus 3. You can write it like this if you like. or you can just say x is the element of, if you don't want to write it like this, minus 3 up to positive infinity, just like that. So that would be it for this particular question. And then the final one, thank you for your patience up until this far. The graph of g is reflected in the x-axis. Write down the new equation in the form of y is equal to. So remember, the graph of g is this. So if you reflect the graph about the x-axis, that means you make y, let me write these notes, you make y negative. What does it mean? That means I'm going to rewrite this graph as minus y is equal to 6 divided by x plus 3 minus 3 over 2. So I've made y negative here, you'll realize. So I'll take this minus sign by multiplying all the equation by minus 1, so that I make y again positive. But when y is positive, that means this side will change to be minus 6 divided by x plus 3, then 3 over 2 will become 3 over 2, which is positive. So this is the new graph here. So we've come to the end of our today's lesson. If you like the video, please hit the like button and consider subscribing. Cheers.